In this video, we are going to find all the real zeros of this polynomial function. F of x equals 2x to the fourth minus x to the third minus 5x squared plus 2x plus 2. And in particular, the way we are going to do this is we are going to use the Rational Zeros Theorem to try to find all the possible rational zeros of this function. And then we're just going to use synthetic division to try these different zeros until we find one that works. So the big idea, often what we do if we have polynomials that are of degree larger than 2, and this polynomial is of degree 4, is we will just try different numbers until and plug them in to our polynomial, or see if they're a zero using synthetic division until we finally find one that works. The issue with this approach is that there are infinite amount of numbers, and so we don't want to try every single number that's out there because that would be impossible. What the Rational Zeros Theorem does is it helps us narrow down the possibilities. So the first thing we are going to do in this problem is we are going to try to find the list of all the possible rational zeros of this polynomial. First, we're going to start by finding p. Now, if we look at our Rational Zeros Theorem, it says that if p over q in lowest terms is a rational zero of f, then p must be a factor of a zero. That's the constant term. That would be this term right here. And q must be a factor of an. That's going to be the leading coefficient. So that's going to be right here. So our fraction, it has to be basically some factor of 2 divided by another factor of 2. All right, so what is that going to look like? I like to just make a list. So I'm going to find all the factors of 2, and that would be plus or minus 1 and plus or minus 2. Those will be all my possible numerators of my fraction, and q will be all the factors of 2, but in this case the 2 is the leading coefficient. They just happen to be the same number. And again, that'll be plus or minus 1 or plus or minus 2. Once I have my list of my possible p's and my possible q's, I find all of the possible fractions. Now, first, I'll just divide everything in the top by what's on the bottom. And so we'll divide everything by plus or minus 1. So plus or minus 1 divided by plus or minus 1 is just going to give us plus or minus 1. And plus or minus 2 divided by plus or minus 1 will just give us plus or minus 2. So these first ones, these first two values come from dividing both of the possibilities for p by plus or minus 1. And we're going to do something similar, except now we will divide every possible value of p by plus or minus 2. So that would be plus or minus 1 divided by 2, right? Plus or minus 1 divided by plus or minus 2, that will give you plus or minus 1/2. And if I do plus or minus 2 divided by plus or minus 2, that would be equal to plus or minus 1. But we already have that in our set, so we don't need to rewrite it down again. So now I basically have 6 different values that I can test in my search of a zero of this function, of this polynomial. And what I like to do is I just start on the left, start with plus 1, then I test negative 1, then I do plus 2, then I do negative 2, etc., until I find a 0. And I'm going to use synthetic division to find these zeros. So I'm going to start with positive 1, and let's see if this works. So I'm going to write down positive 1. I'm going to test, is positive 1 a 0? Here are my coefficients in order from my polynomial. I'm actually going to get rid of these pluses. I don't need those. And again, that just comes from the coefficients of the polynomial. Bring down the 2. 1 times 2 is 2. And now I add these two. Negative 1 plus 2 is just 1. 1 times 1 is 5. I'm sorry. 1 times 1 is 1. And then I subtract, or I do negative 5 plus 1 is negative 4. 1 times negative 4 is negative 4. 2 plus negative 4 is negative 2. And 1 times negative 2 is negative 2. And 2 minus 2 is 0. And I got lucky, and I found a 0. So since this is the remainder, since the remainder is 0, that means 1 is a 0 of f of x. That also means that x minus 1 is a factor of f of x. And so I can actually rewrite f of x like this. I have my factor x minus 1, and what's left over when I factor out that x minus 1 will be precisely this polynomial. So it'll be, now remember, we started with x to the 4th, so my first term in this polynomial would be x to the 3rd. We just go down 1 when we divide using synthetic division, plus 1x squared minus 4x minus 2. All right, so this is great. Now, what I'm going to do next is, now I've already factored this out, I'm going to find the factors of this new polynomial next. And the possibilities are still the same as the ones that we have originally. Okay, you don't need to make a new, apply the rational roots theorem again. You can just continue to use the same possibilities that you found at the beginning. One thing that is important, it is possible that 1 will also be a root of this new polynomial. So don't skip a number that you've already tried, because maybe it is a 0 of multiplicity 2 or higher. So again, I'm just going to start at the beginning. I'm going to start with 1, and we are going to try that out. Again, here are my coefficients of the new polynomial. And let's see if this works. Bring down the 2. 1 times 2 is 2. 1 plus 2 is 3. 1 times 3 is 3. Negative 4 plus 3 is negative 1. And 1 times negative 1 is negative 1. And we end up with a remainder of negative 3. Unfortunately, that didn't work. So we move on to the next number in our list, which is negative 1. And we go through that whole process again. Bring down the 2. Negative 1 times 2 is negative 2. 1 plus negative 2 is negative 1. Negative 1 times negative 1 is positive 1. Negative 4 plus 1 is negative 3. And negative 1 times negative 3 is positive 3. And we have a remainder here. So this is also not a 0. So I've tried plus or minus 1, or I've tried positive 1 and negative 1. Now I'm going to do the same for positive 2, then I'll try negative 2. If it still doesn't work. Hopefully Positive 2 will work, but we'll see. Bring down my 2. 2 times 2 is 4. And this becomes 5. 1 plus 4 is 5. 2 times 5 is 10. Negative 4 plus 10 is 6. 2 times 6 is 12. And we end up with a remainder. All right, so that one didn't work. And this is what will happen sometimes is, you just might end up trying many different numbers until you find the one that works. All right, let's try negative 2. Bring down the 2. Negative 2 times 2 is negative 4. 1 plus negative 4 is negative 3. This ends up being negative 2 times negative 3 is positive 6. Negative 4 plus 6 is positive 2. And negative 2 times 2 is negative 4. All right. So now we've tried plus or minus 1, plus or minus 2. Now we have to try plus or minus 1/2. And it is possible that we don't find another rational root, in which case we'd have to figure out a different method. It's possible that the roots are irrational numbers, the remaining roots. All right, bring down our 2. So this ends up being 2. Half of 2 is 1. 1 plus 1 is 2. Half of 2 is 1. Negative 4 plus 1 is negative 3. Half of negative 3 is negative 3 halves. And this ends up being, I think, negative 7 halves. All right, so that one didn't work either. Let's keep our fingers crossed that negative 1/2 will work. Bring down the 2. Negative 1/2 times 2 is negative 1. This ends up being 0. Negative 1/2 times 0 is just 0. We end up with negative 4. Negative 1/2 times negative 4 is positive 2. And lo and behold, the last one ended up working. Okay? Like I said, this will happen sometimes. Okay? It could have also been possible that there were no more rational roots and we would have had to try a different method. All right, so what does this tell us? So negative 1/2 is a 0, which means x plus 1/2 is a factor. And what I'm really going to do in this part right here is I'm going to replace this. I'm going to factor out that x plus 1/2. So this becomes this. And then what's left over here, this is going to be, again, we started in this case with a polynomial of degree 3. We divided out x plus 1, so we're going to be left with a polynomial of degree 2. So this will be 2x squared minus 4. And that just comes from this right here. Oh, I did a mistake here. I'm seeing I wrote down x plus 1, and I meant to write 1/2. So my apologies. Hopefully that didn't confuse anyone too much. All right. So at this point, we have found 2 of the zeros, but there are potentially up to 2 more. Remember, the number of zeros in a polynomial will be less than or equal to the degree of that polynomial. But once you get down to a quadratic, it makes the most sense to use a different method, because we have learned a lot of tools for how to factor and find the zeros of a quadratic. For this problem, I think the easiest thing to do, since we are missing the x term, is just to solve for x manually. So I'm going to solve for x. I'm going to add 4 to both sides. And again, I am just looking at this remaining polynomial, 2x squared minus 4. And I'm going to try to factor that out and find the zeros. My 4's cancel out. And then I divide both sides by 2. These 2's cancel out. I'm left with x squared equals 2. Take the square root of both sides. Make sure you put the plus or minus here. And we get our last roots. Okay? I also wrote this incorrectly. It should have looked like that, so my apologies. All right, so now I can find the totally factored version of my original polynomial. And since these are my two roots, that means my two factors will be x plus the square root of 2 and x minus the square root of 2. Okay? So in this process, we've actually done two things. We found the factored form of this polynomial, and we've also found all of the zeros. And those are going to be 1, negative 1/2, square root of 2, and negative square root of 2. And at this point, we are done with this problem. Okay? And I think this is a good example of, not every problem is going to work out nicely. Sometimes you have to literally try every zero before you get the one that works. But we were able to solve this just fine. Let's check our work before we go. Again, just get out your graphing calculator. And let's enter in the original equation, which was 2x to the 4th minus x to the 3rd minus 5x squared plus 2x, I think it was plus 2. All right, let's look at our zeros. So that's the negative square root of 2. If you put square root of 2 in your calculator, you'll get negative 1.41421. Here we get negative 1/2. Perfect. Here we get 1, and here we get positive square root of 2. So we know that we did this correctly. Okay? All right, I really hope that was helpful. Have a good rest of your day, and we will see you in the next video.